Hello everyone, and thank you for watching my 248 video tutorial. In this lecture I decided to take a short break from coding and to take a closer look at the rules of the original 248 game. So in these first couple of slides, the main idea that I wanted to get across is if we are making right or left moves, only the rows are affected. So each row is isolated from all the other rows, and we don't have to know any of the information about the tiles in the other rows to predict an outcome of our move in any particular row. And the same is happening with columns, so up and down moves, they affect only tiles in our columns, and all the columns happen to be separated from each other and isolated. So this leads us to another interesting observation. If we build our game logic to move the tiles for us just in a single line, we can then apply this logic to calculate moves for us in each given row or in each given column, depending on the direction of our move. So all the moves on the game field in the 248 game, they can be decomposed, and we can just consider moves in separate lines. They might be rows or they might be columns. And in this next slide, I just wanted to remind you about the numeration of the tiles on our game field. So we have our rows and we have our columns, and this is the first row and this is our fourth row, but we know that in coding all the indexes start from 0, so this will be the row with number 0, this will be the row with number 1, and our last row will have an index of 3. And the same thing with columns, so the first column will have a number of 0 and our last column will have a number of 3. And these numbers that are written on our tiles, they are just indexes in our all tiles array. So this tile will have an index of 0, 0. This tile will have an index 2, 3. So this slide is here just for the sake of reminding you of the numeration on our game field, because it will be important later for us when we write game logic that will make moves on the game field. So on this slide I wanted to introduce another breakup of our moves into two categories, which will be up index and down index moves. If we are making right moves or if we are making down moves, these moves will fall under our category up index. What I mean is that we will move our tiles from the lower indexes to the higher indexes, and on another slide, if we are making up or left moves, these moves we are going to call down index, because in order to make these moves, we'll be moving our tiles from the higher indexes to the lower indexes. That's why we come to this interesting paradox that up and left moves will be more similar in code than left and right moves. And our main purpose of doing this is to prevent from producing duplicate code, because we could have written 4 separate methods for right move, down move, up move, and left move. But this is really not necessary, because we will have all our moves covered by just these two methods. So in code we will write two methods, move up index and move down index, and this is basically all we need. And on this next slide there is another very important point that will help us separate our moves into two main categories. First will be move one tile to an empty spot, and then we will have another category which will say merge two neighboring tiles. If, say, we have this row and it has only number 2 tile in it, and our player chooses to move all the tiles to the right, we are starting to look for our moves from the right, and the first tile that we have turns out to be an empty tile, and when we encounter the next tile that is filled with this number 2 tile, we just have to swap these two tiles. And what we'll do to swap these tiles in code is we will change their number properties. So for this first empty tile we're going to set its number property to 2, and then the number 2 tile will appear on this spot. And for this number 2 tile we will set its number public property to 0, and this way we will make this tile empty. This concludes our move one tile to an empty spot. And our next elementary move is merge two neighboring tiles. And if we are moving right, we will start scanning our line for moves from the right. And as you can see, we have two similar tiles. So what will happen for this tile that is closest to the right, we will set its number public property to 4. So this tile is going to be changed for a number 4 tile. And this tile will be set empty by setting its number property to 0. So these two elementary moves are very simple and straightforward. This is just a scheme of how we will be looking and scanning our lines for moves. So no matter where we move, we will always start looking from the direction that we're moving to. So if we are moving right, we'll start scanning our tiles for available moves from the right, and if we are moving left, we will start to scan our tiles for moves from the left. The same applies if we are moving up or down. And in these next couple of slides, I wanted to provide a couple of examples of how we make our moves step by step. So let's say we have a number 2 tile, then we have a blank space, then we have another number 2 tile, and then another blank space. If we move to the right, we are starting to scan our line for moves from the right. In our first scan, we compare these two, and we can see that we have our elementary move available, so this empty tile and this number 2 tile will be swapped, which will lead us to this situation in our row. Then we will start scanning again, then we will have to go all the way to find another available move, which is this number 2 tile and this empty tile, and then they will be swapped. And I didn't include this another move, so after this number 2 tile moves one tile to the right, we then have another available move here, so we will swap once again and we will get eventually to this situation. And after we have moved both tiles to the right, we will discover that there is a merge available, and then these two number 2 tiles will be merged and they will form a 4. And this concludes this very simple example. And our next example is a bit more complex. So we have a blank space, we have 2 8 and 1 4, and our user chooses to move this line to the left. So first we will scan these 2 tiles, and we can see that we have one move available, so we will move our 8 to the left, and then we will start scanning again and we will find our move on our second iteration. So we will find this 8 and this empty space and we will swap them, and then it seems like we have a merge available, but first we have to exhaust all the moves, so we have to make all the moves before we switch to merges. So we start to search for moves again, and we find that we have another primitive move. We can move this number 4 tile and swap it with this empty tile, and only after that we can merge these 2 8s, because we don't have any more moves available in our line. And then after merging our 2 8s, we will have one 16 tile and one empty tile, and then we start scanning our line for moves again, and we find this 4 tile and we can swap these 2 tiles, and in the end we end up having this picture. So we will have one number 16 tile and one number 4 tile. But the actual sequencing of these moves is also very important, so that we understand better how the algorithm of moving our tiles on the game field will work. And this last slide that I decided to include, we have another rule in the 2 for 8 game. It says tiles merge only once. So once the tile has been merged, it cannot participate in any other merges. So if we have this situation when our player decides to make the move to the right in the original 2 for 8 game, he will end up having 2 number 16 tiles, and these number 16 tiles, they won't be merged into 32, because this number 16 tile, it is already a product of merging that has happened on this turn, so it will not merge once again and form a 32 together with this 16 tile. So in order to form this number 32 tile, we will have to make a right move one more time. And there is another situation when we can use this rule. So if we have a situation similar to this one and we are trying to make a right move, first these two number 2 tiles will be merged and they will form this number 4 tile, but we will have a blank space here, so we'll have to make our primitive moves until both of these number 2 tiles end up here closer to the right border of our game field, and then they will be merged into another 4, and further merges will not happen because both of these 4s have participated in merges this turn. So in order to get an 8, we will have to make another turn and press right once again. I hope that this little presentation was useful and that it has provided some more information about how the moves are made and about the main algorithms and tricks that we will use while writing the code for moving the tiles and merging the tiles in our game. So thank you for watching and see you in the next video.